Hi student, hello, good evening. So today we are going to see the question number 64. Okay, so 64, and this is related to what? Transmission line. What? Transmission line. And here the question is given as here a radio frequency signal, RF signal is applied. RF signal is applied to the transmission line. Okay, so lossless transmission line whose characteristic impedance is 50 ohm. So that is applied to the 50 ohm lossless transmission line. Okay, so this RF signal is applied, and here and the load terminal is what? Load terminal that is terminated with the load impedance of what? The load is terminated with the impedance of J50 ohm. J50 ohm, and the wavelength of the signal that is given as 8 centimeter. Okay, so 8 centimeter, and he is asking about what? Asking about what is the voltage maxima and what is the voltage maxima and current maxima alternatively. What? Alternatively. So let us see how we can calculate this voltage maxima and current minima near the load, near the loop. First of all, what we have to do? So what is the requirement that we need to calculate the voltage maxima and current maxima? So first of all, as we know very well, what we know, the voltage, what voltage V of x, that is what traveling along the transmission line of length x, of length x. Let us say this length is what? X is equal to 0. Here this length x is equal to what? L. Okay, x is equal to L at load side. Okay, so now see the voltage that will vary along the transmission line as Vx is equal to what? V forward voltage. Okay, so this is what? V forward voltage into the power j what? Beta x, j beta x. Okay, so j beta x plus this is forward wave. Okay, so forward traveling wave which is traveling through the transmission line, and there is also some refracted wave. Okay, so this is what? My refracted wave which will get reflected from the load toward the source. This is my refracted voltage. This is Vr into e to the power what? Minus j beta x. Yes, minus j beta x. This is my what? Voltage. Okay, RF signal that is traveling through the transmission line. Okay, so now as a function of what? X, as a function of distance x. Now we want to find what? This reverse voltage, that is reflected voltage from the load in term of what? Vf. How we can calculate that? This is nothing but in term of reflection coefficient. As we know very well, reflection coefficient is what? Reflection coefficient tau is equal to what? Is equal to V reflected voltage upon V forward voltage, which implies that V reflected voltage is equal to tau into Vf. Okay, so this is my V reflected voltage. V reflected voltage. Okay, so now this is what? Reflection coefficient, voltage reflection coefficient. Now let us first calculate this voltage reflection coefficient also. See here, voltage reflection coefficient. Just okay, so first we will put this here, and after that we will calculate this reflection coefficient. Okay, reflection coefficient. Now just put this reflected voltage here. What we will get? V of x. Okay, V of x is equal to Vf e to the power j beta x plus what is this? V reflected voltage, that is nothing but reflection coefficient into Vf into e to the power minus j beta x. Okay, so minus j beta x. What we did? Nothing, just converting, just we have written this reflected voltage in terms of forward voltage. Okay, so with the help of reflection coefficient, as we know very well, reflection coefficient, it is the ratio of the reflected voltage upon forward voltage. Okay, so now let us take this Vf common. What we will get? Vx. What we will get? Vx is equal to Vf. Take this common here. Vf into e to the power j beta. What? E to the power j beta x plus this is what e to the power j beta x, j beta x plus reflection coefficient e to the power minus j beta x. Yes, minus j beta x. So now this is what forward voltage. Now see here what we will observe here. This is what reflection voltage, reflection coefficient. Okay, so now let us calculate this reflection coefficient. Okay, reflection coefficient. What is reflection coefficient? Let's see here. Reflection coefficient tau is equal to what? Load impedance minus characteristic impedance divided by load impedance plus characteristic impedance. Okay, so this is what reflection coefficient is equal to how much is load impedance. This is j 50 ohm minus 50 divided by how much? j 50 plus 50. Then tau v is equal to take 50 common. This is j minus 1 divided by 50 into j plus 1. Now what we will get here? We will get reflection. Okay, so reflection coefficient is equal to j minus 1 divided by j plus 1 is equal to, if we see this 1 angle, what is this angle? J minus 1 means it is 180 degree minus 45 degree. So this is what? This is 45 degree. This also here minus 45 degree. Okay, so as you know very well, j minus 1 is nothing but j minus 1. So let's see at above. Okay, so I think below it is not visible. So up to this is clear. Okay, so up to this is clear. So let us see here. Now where we are, just here, v of x is equal to vf forward voltage. Okay, so into e to the power j beta x plus e to the power minus j plus reflection coefficient, voltage reflection coefficient e to the power minus j beta x. Okay, j beta x. So now if we see here vx, reflection coefficient is nothing but that we got how much? j minus 1 divided by j plus 1. Okay, j plus 1. Now see here, magnitude how much? Root 2. Angle j minus 1, how much is this? 180 degree minus 45 degree. Okay, so how we can calculate this? Let us see here. j minus 1 is equal to, if we see this, okay, so this is imaginary, so it is positive, means this imaginary is positive quantity, and this is what real is negative. So angle is somewhere here. This angle is somewhere in second quadrant means this is what? 180 degree minus 10 inverse imaginary part, how much? 1 upon real part 1. Okay, so real part 1. So why we took? Because here real is negative, means this negative, and imaginary means positive. This means second quadrant. So that's why we wrote what? 180 degree minus 10 inverse 1 by 1. Okay, so actually it is what? If we see the originally, the angle is 10 inverse. Imaginary is what? 1. Imaginary 1, and this is what? Real minus 1. So see, this real is negative. Okay, so this is negative axis, and this is what? Positive means what? This is second quadrant. So therefore we have to write what? 180 degree minus 5 with positive quantity inside the tan inverse. Okay, so that is the way to write every angle. Okay, so now see here, down is what? So this is nothing but root 2 angle. So now see both quantity are positive, both are positive. See here, j plus 1 is equal to what? J plus 1. If we want to write the angle for this, how we can write? Phi is equal to what? Phi is equal to tan inverse. This is what? Positive quantity 1 divided by, this is what? Real also positive, both are positive, so therefore there is no sign. Yes, so means the angle is in first quadrant. Tan inverse 1 is nothing but 45 degree. Hence we can write for j plus 1 angle is how much? 45 degree. And you know this magnitude is for both root 2, this is a square plus b square, root a square plus b square. Okay, so now this is the way, this is the way to calculate any angle. Okay, so if you want to calculate any angle, just you see this imaginary axis and you see this real axis. Okay, real axis, imaginary axis, whatever the angle is this. Okay, so let us say this is my phi is equal to what? Tan inverse. This is my imaginary part, imaginary upon real, imaginary upon real. Then you see real, whether it is positive or negative, both you check, if both are positive, then my angle is in first quadrant. If imaginary is negative and real is positive, then my angle is what? My angle is in fourth quadrant. Okay, so if both are positive, my angle is just phi. Okay, phi equal to tan inverse whatever the quantity is inside. Okay, so now if imaginary is negative and real is positive, then my angle is in fourth quadrant. Then how I can write just minus. Okay, so minus tan inverse whole quantity inside what? Inside tan inverse is positive. Tan inverse is positive. Okay, here also whole quantity positive, and it is lying in second quadrant. If imaginary, okay, if imaginary is negative and real is also negative, both are negative, means it is in third quadrant. How you will write this angle? Then this angle you can write phi is equal to what? 180 degree plus tan inverse whole quantity inside the tan is positive. This is the way to write this angle. Okay, if imaginary is what? If imaginary is positive, real is negative, then it is second quadrant. That time you will write phi is equal to what? 180 degree minus tan inverse whatever the quantity inside tan inverse, that is positive. So this is the way to write what? Angle, every angle. Okay, so this is the way to write that angle. So now this is just to understand the concept of what? Angle. Okay, how to write the angle. Now see what is this now? This is root 2, that will get cancelled. Okay, so this will get cancelled and we are left with what? We are left with, this is 180 degree minus 45 degree, this is 45, this will come up, how much is this? 180 degree minus 90 degree. Okay, so this is what? This is nothing but one angle 90 degree. Okay, so 90 degree. So what we got here? Reflection coefficient, reflection coefficient is equal to 1 angle 90 degree. 1 angle 90 degree. 1 angle 90 degree. Okay, so this is my reflection coefficient. Now just put this reflection coefficient here. Okay, so now put this reflection coefficient in this equation, what we will get. Okay, so now see here, Vx is equal to Vf into e to the power j beta x plus reflection coefficient that we got, how much? 1 angle 90 degree. one angle 90 degrees. E to the power minus j beta x. Yes, minus j beta x. So now minus j beta x. Now see here. Now we want what? We want to find voltage maxima and current maxima alternatively. Okay. So now first see here, v of x just modified somewhat. So we have e to the power j beta x plus what is this angle? So angle 90 degree. Thus this I can write j 90 degree into e to the power minus j beta x. Okay, so this is what. Now see here, v of x is equal to vf. Okay, v of x is equal to vf e to the power j beta x plus e to the power j beta x plus e to the power j beta is how much is this? This is nothing but take j common. Okay, so j into 90 degree minus beta x Okay, sorry. Okay, so this is what v of v x is equal to vf e to the power j beta x plus j 90 minus beta x. Okay, so now see here upside. Now see upside. How much place is there? Okay, so now see here. What we got here? V of x is equal to vf e to the power j beta x plus e to the power j 90 degree j 90 degree minus beta x. Yes, so this is my voltage v of x. So now we want to find what? Voltage maximum. This is my angle. Okay, angle of what? Forward wave, angle of backward wave. Okay, so backward wave. This is what? Phase. This is phase, forward phase, backward phase. Okay, so I can write this as v of x is equal to vf into e to the power j forward phase, yes, plus e to the power j backward phase. Okay, so backward phase, forward phase, backward phase. Now voltage maxima, as we know what we know, v maxima voltage maxima occur when both forward and backward wave are in phase. Okay, so when forward and backward wave both are in phase, that time voltage maxima occur. What? That time voltage maxima occur. Now for that both angle difference should be within the phase. Okay, so when both forward and backward waves are in phase, then voltage maxima occur for which this angle difference. Okay, this angle difference must be in phase. That means angle difference is what? This forward angle minus this reverse angle, backward angle, must be equal to what? Must be in phase. In phase means 2 and pi. Yes, 2 and pi. We should understand. Okay, so when voltage maxima occur only if both forward and backward wave occur in phase. In phase means the phase difference of forward and backward should be in what phase? In phase 2 and pi. Okay, so this is the condition for voltage maxima. Then voltage maxima, similarly voltage minima occur when voltage minima or current maxima. Voltage minima or current maxima occur when this phase, when both forward and backward wave Forward and backward wave are out of phase. What out of phase? When both waves are out of phase, then that time we obtain V minima. Then voltage minima occur. Voltage minima occur only when both forward and backward wave are out of phase. Out of phase means the phase difference. Phase difference must be out of phase. Out of phase means this is what phase difference phi f minus phi b. Forward minus backward is equal to out of phase means 2n plus 1 into what pi 2n plus 1 into pi. Okay, so this is what condition for voltage minima. When voltage minima occur when both waves are out of phase. Out of phase means the phase difference must be equal to 2n plus 1 into pi. So now see here, voltage maxima means first voltage maxima occur. First voltage maxima occur when? First voltage maxima, V maxima. This is my first voltage maxima. Occur V phi. What is V phi? V phi is nothing but J. This is nothing but beta x. V phi minus, this is phi f. Phi f is beta x minus phi b. What is phi b? 90 degree. 90 degree. Minus plus. This is beta x. Okay. So beta x, which is nothing but equal to 2 beta x maxima. Yes. 2 beta x maxima minus 90 degree. Okay, so this is my voltage maximum. This voltage maximum must be equal to what? Must be, let us write above. So this is, let us write this here. Space is somewhat less. See, voltage maxima. So voltage maxima, that we got how much? Phi forward minus phi backward is equal to 2n pi. Okay, 2n pi. For which we have seen that phi f is how much? Beta x maximum. Minus phi b is nothing but 90 degree minus beta x minus plus. Okay, so plus beta x maximum. Okay, so why? Because if you see here phi f is how much? Phi f is beta x and phi backward is minus beta x plus 90. Okay, so see here, this is beta x maximum. Means what? How much? 2 beta x maximum is equal to how much? 2 beta x maximum minus 90 degree must be equal to first voltage maxima, means n is equal to 0. So it is 0 for first voltage maxima, n is equal to 0. So therefore this angle difference is what? 0. Okay, so therefore from here what we can write? 2 beta x maximum is equal to what? 90 degree. Okay, so 90 degree and 2 beta x maximum 2 beta x maximum is equal to what? X maximum is equal to 90 degree means pi by 2. Pi by 2. So beta x maximum is equal to how much? Beta x maximum equal to pi by 4. So beta x maximum. So x maximum is how much? So x maximum is equal to this is pi by beta 4 beta. How much is beta? Let us calculate. Beta is equal to 2 pi by lambda. Okay, 2 pi by lambda. Now just put this value here. Beta is equal to 2 pi by lambda, so it is pi divided by 2 pi by lambda. This is 4 Yes, 4 into 2 pi by lambda into lambda. So this is what lambda. So it is pi get cancelled and we are left with lambda divided by 8. Lambda divided by 8 and lambda is given as 8 centimeter. 8 centimeter divided by 8. So which is nothing but 1 centimeter. 1 centimeter. 1 centimeter. Okay, so 1 centimeter. So our voltage maxima occur at what? Voltage maxima occur at 1 centimeter. Okay, so 1 centimeter. So at a distance of 1 centimeter near the load, voltage maxima occur. Voltage maxima occur. So V maxima first voltage maxima occur at x. At x is equal to what? At x is equal to 1 centimeter. 1 centimeter. Okay, so 1 centimeter. So this is for voltage maxima. Now see for current maxima. For current maxima. See here for current maxima, what we will get, at what distance we can get current maxima. So current maxima is just similar to voltage minima. Okay, so that is what current maxima. So current maxima is similar to voltage maxima. Okay, voltage minima. Okay, either you can tell, either you can call it as I maximum. Okay, current maxima or voltage minima. For voltage maxima, either you can call also it as what? Current minima. When voltage minima or current maxima occur, when both forward and backward wave occur, what? Occur in out of phase. When both wave are out of phase, so then their phase difference must be out of phase. Okay, so this is what? Phi f minus phi b, that must be out of phase, means what? 2n plus 1 into pi by 2. 2n plus 1 into pi. Okay, so out of phase by what? Out of phase by 180 degree. When both wave are out of phase by 180 degree, so multiple of 180 degree, then that time we always get what? We always get voltage minima or current maximum. So what is phi f? Forward angle, which is nothing but beta x minimum. Okay, so this is for current maxima. So current maxima. Okay, so you can write this also x maxima, but we are writing for voltage minima in term of minima. So this x minima. Okay, x minima, you can write x maxima also, because in term of what? Current. So we can write x maxima also. You can write x maxima. Yes, x maxima, which is opposite to that of voltage maxima. Yes, current maxima, which is similar to voltage minimum. So beta x maxima minus phi b is what? 90 degree. Okay, so 90 degree minus plus what? Plus, as we know, phi b is minus beta, minus plus, so plus beta x maxima. So let us write this x minima. It will sound better. Okay, it will sound better. Why? Because we are calculating in term of voltage. Okay, so x minima. Okay, so that is equal to what? That is equal to out of phase by 180 degree. So this is 2n plus 1 into pi. So into pi, so beta x minima, that is what? 2 time of beta x minima, 2 time of x beta minima minus 90 degree pi by 2. Yes, we can write in term of radian. Okay, so first voltage minima, n must be equal to 0 for first voltage minima. So here we will get pi. Yes, so therefore 2 beta x minima. 2 beta x minima is equal to what? Is equal to this pi by 2 will come here and we will get 3 pi by 2. Okay, pi plus pi by 2 is nothing but 3 pi by 2. Now 3 pi by 2 and 2 beta is what? 2 pi by lambda. Beta is 2 pi by lambda into x minima is equal to what? Is equal to 3 pi by 2. Yes, pi get cancelled from here. Okay, so what you will get here? Lambda is 8 centimeter. Yes, So this is 4. So x minima, that you will get x minima. This lambda will come this side. So this is 3 lambda divided by 2 into 4. Yes, which is nothing but 3 into lambda is how much? 8 centimeter. 8 centimeter divided by 8. So 8 will get cancelled. 8 will get cancelled, and we will get voltage minima. Okay, so voltage minima means x minima is equal to 3 centimeter. 3 centimeter. Okay, so this is for x minima, for voltage minima. For current maxima, it is x maxima. X maxima is equal to 3 centimeter. 3 centimeter. Okay, so therefore we get what? X minimum is equal to 3 centimeter. So for current maxima, we get X maxima. X maxima is equal to 3 centimeter. 3 centimeter. Whenever we call this as a current maxima, that time we will call this x minima as x maxima for current. Okay, so therefore x maxima for current is 3 centimeter. 3 centimeter. So therefore we got what? We got v maxima at the distance of x is equal to 1 centimeter. We got current maxima at x is equal to 3 centimeter. Yes, so we got voltage maxima at x is equal to 1 centimeter, and we got current maxima at x is equal to 3 centimeter. This at 1 centimeter. Okay, so this is all about what? All about voltage maxima and current minima. Okay, so just how we have to deal this type of problem. So first of all, we have to write the general equations of the voltage signal, that is like this radio frequency signal that is transmitted through the transmission line, and here as the waves will get transmitted through this transmission line, and some of the portion of the same wave will get reflected backward from load to source. Okay, so right, like that we have to write first these equations, and after that we will get the angle. Okay, so we will get angle that is e to the power j beta x, which represent what? Propagation of the wave through this transmission line. Okay, so then after that we will get when voltage maxima will occur. So when the angle difference is what? Out of phase. Angle difference is in phase, that time we will get voltage maxima, and when the angle difference is out of phase by 180 degree, odd multiple of 180 degree, that time we will get voltage minima. Okay, and correspond to that we will get current maxima. Here voltage and current, because they are reciprocal to each other, so therefore whenever we are calculating the voltage maxima, there we are getting current minima, and where we are calculating the voltage minima, there we are getting current maxima. Okay, so that's all for this question. Okay, so about transmission line, where we have to calculate the voltage maxima and current maxima respectively. So okay, thank you very much to support my channel and to see my video, and thank you very much.